everyone. In this today's class, we are going to simplify two more problems based on three variable Karnaugh maps. Now, here is the question. Simplify the following Boolean expressions using three variable K-maps. Now, here they mentioned two examples. Firstly, we will simplify the first example. The first one is x and y plus x bar and y bar and z bar plus x bar and y and z bar. Now here in this Boolean expression, some variables are missing. Means it is in just a canonical form of expression like sum of product form. Now we need to convert this SOP function into standard sum of product expression. Means here we are going to find a standard sum of product expression. Means SOP expression for this first example. Now here we need to follow some procedure. For the given example 1, if we observe the first product term, here the variables x and y are present. And for the second product term, the x bar, y bar and z bar, three variables are present. And coming to the third product term, x bar, y and z bar is present. Means in the first product term, only the z variable is missing. So to convert this expression into standard sum of product expression, we need to follow this procedure. That is, for the first product term, we need to multiply whatever the variable is missing here. By considering that variable, we need to multiply x and y with z plus z bar. And second product term and third product term we written here as it is given in this example. And after simplification, these are the minterms we find here. And if we write function of x, y, z is equal to sum of, here the product term x and y and z is going to represent the minterm M7. So here we are writing 7. And x and y and z bar, this minterm is going to represent M6. So here 6. Similarly, this product term is for M0, so 0 here, and this minterm is like M2 here. So we are writing 2 here. So this is going to be the mentioned example Boolean expression. Now we need to simplify this Boolean expression to a simplified Boolean expression. So here we are using three variable Karnaugh map here, and we need to consider to the row side x variable and to the column side y and z variables. So for the first row, x bar variable will be common. For the second row, x variable will be common. And similarly, for the column wise also, we are taking y z variables are common in this fashion. Now here, when we are simplifying a expression by using three variable K-map or four variable K-map, we need to follow some rules. Like here, the first rule is always group a larger number of ones which are in adjacent squares. When we are assigning ones in the K-map, we need to group those adjacent ones. So when we are combining adjacent ones, we need to give priority to combine like 8 number of ones or 4 number of ones or 2 number of ones. If we are combining 8 number of ones, that group is going to give octet. And if we are combining 4 number of ones, that group is going to give a quad. If we are combining 2 ones, and it will give group as a pair. So we need to always give priority to combine more number of adjacent ones. The second rule is cover all the minterms mentioned in the function at least one time by grouping. So when we are grouping adjacent ones, all the minterms, whatever the minterms present in that function, it should be covered at least one time. And the third rule is find a simplified Boolean expression. We need not to repeat the redundant product terms here. Now we will simplify the given function. So here the minterms present are 0, 2, 6, 7. So at that particular minterms location, here we need to assign 1. So minterm M0 means here 1. For M2, here 1. For 6, here 1. And for 7, here also 1. Now we assign it the minterms. Whatever the minterms are present in this function, we assign 1 here. Now we need to group these adjacent ones. So if we observe this 3 variable K-map, here in M0 place we have 1, in M2 place we have 1. So we need to group these two ones. By this grouping, we are making a pair here. Now next we will group these two adjacent ones here in the place of M6 and M7. These two ones are adjacent to each other. So we are grouping these two ones. And the product term we can write here. Here for these two ones are in the second row and the variable x will be common. And these two ones are in third column and fourth column. Here y variable is common. Z will be changing. So the product term will be x and y. And coming to this group, we can write the product term here. X bar will be common and y is changing. Z bar will be common. So the product term will be x bar and z bar. So the simplified expression for this first example, we can write it as x and y plus x bar and z bar. Now we will see the second example. Here is the question: a bar and b plus b and c bar plus b bar and c bar. Now this given expression is not in a standard form. Firstly, we need to find the standard sum of product expression. For that one, here if we observe for the given expression, first product term c variable is missing and second product term a variable is missing and third product term a variable is missing. So in this conversion of standard SOP function, whatever the variables are missing in these product terms, we need to multiply with those product terms by, if c is missing means we need to multiply with c plus c bar. As already we know, the variable like normal variable or with complement variable is gives equal to 1 here. So after multiplying and simplification, we may find the Boolean expression as sum of minterms like 3, 2, 6, 4, 0. Here the minterms a bar, b, c bar, a bar, b, c bar are repeating 2 times means we need to consider only 1 time. And here for each respective product term, here we written the minterms. And whatever the minterms present in this function, for those minterms, we need to assign 1 in this 3 variable K-map. So we assign an M0 place, in M2 place, in M3 place, M4 and M6 place. And after assigning the ones here, we need to combine the adjacent ones. So here, if we observe this 3 variable K-map, here M0 and M4 are adjacent, M2 and M6 are adjacent. And we left over only with this M3 midterm. So to combine this M3 midterm, the adjacent cell M2 is also having 1 here. And by grouping these two cells, we can make a pair. So if we are combining 4 cells, means it will give a quad. If we are combining 2 cells, it will give a pair. Now we will write the product terms. So for this quad, the product term will be the variable a is changing, and considering first column and last column, the b variable is also changing. C bar will be common. So for the quad, we find C bar is the product term. And coming to the pair group, here A bar variable is common. So take A bar. Third column and fourth column if we observe, B variable is common, C is changing. So take B variable is common, changing variable will become 1. So finally, the simplified expression function of A, B, C will be equal to C bar plus A bar B. So by following these procedures, we can easily find the simplified Boolean expressions. Thank you.